Nice. All right, I'm going to, just as a reminder, in case people can't join, I'm going to
I'm
record.
on a Zoom. I'm getting on a Zoom call for Matt.
All right, Matt, here we go.
Uh,
All right, so feel free, anyone can jump in, just kind of raise your hand as one does on Zoom, and I'll get to, because if you raise your hand, once I get into, raise your hand on Zoom, however one does that, but then it'll pop up even on my screen when I'm in the share mode, when I'm sharing my iPad. So let's jump in. It always takes the longest for the first question to come.
I was wondering if we could do a practice problem, or if you think it'd be relevant to a practice problem where we're given a domain and range and have to make a function for both, in, like combined.
And that meets both conditions?
Yeah.
Sure. Why not? Yes, we'll do one of those. Okay, I'm going to share my iPad here. Hold on. Give me 1 second. We're sharing a window on another desktop. Nope. All right, hold on. I just had this working. No one saw the iPad there, did they?
No.
Okay, let's try this again. All right, there we go. Okay, so, all right, I'm just going to put up a blank doc here. All right, so find a function. Let's do this. Find a function with, I'm going to do a little bit different than the one that was on one of the practice sheets. So with domain, let's do, um, negative infinity, um, -2, union -2 to infinity, and range. This one's gonna be a little bit, maybe a little bit too challenging, but you guys can, I feel like you guys can do this. Okay. So try that. And there's not just one answer. Like with all of these, multiple functions may meet this condition. And while people are thinking about that, feel free if anyone else has a question they want to jump in with. Give it one more minute and then we'll talk about kind of the best way to approach this. So you always want to consider the domain first, and then we can deal with making sure the range fits. And really, in terms of these types of problems, I'd only have you deal with two different types of things that you want to think about. If a whole range of values is missing from the domain, then you want to think, okay, maybe something under a square root. If just very specific discrete values are missing, then I think denominator equaling zero. So what would we think in this case?
Denominator.
Yeah, I'm just the only thing that can't be part of is that's not part of my domain or that is excluded would be -2. So I might think, at the denominator having x plus 2, right? And I actually in the numerator, I really could have many different numbers in the numerator. Maybe one just wants to put 1. So once you get the domain rather taken care of, then you want to ask yourself, okay, what's the range of what I have right now? So the function I've created, or if you created a function with a single fraction, what would be the range of what I have right now?
Negative infinity to zero, zero to infinity.
Yes, exactly. The only thing that would be excluded would be 0. But I want the only thing to be excluded to be 3. So what's a simple way to change that?
You
Plus
just
two,
add
add
3.
three.
Yep, exactly. Just add 3. Yep, that's it. And truth is, I could have had 4 up here, right? I didn't have to have 1 up there. Um, so many different infinite things you could have up there. Okay. What else you got?
Could we do like absolute value transformations?
Yeah, give me a type of problem you want.
Um, like it's like f of the absolute value of like x plus 5.
No, I
Something.
mean, do you want the
Yeah.
type of problem, where does a point go? Where does changing the graph or changing the domain and range?
Changing the graph. Like
Okay, let's do one. All right, so if I have a graph, although you'll probably regret asking this given my drawing by hand skills, not the best. Um, okay, so I'll make something weird up, but something that has a finite domain. All right, let's do. Maybe something like that. Okay. And I'm gonna do something a little bit different. So let's see if I do, um, all right, we'll call this f of x, by the way. So f of x, let's do, and then minus, okay, something like that. So lot going on. So thinking about how you would approach this. And then I'm checking the chat because I see people wrote stuff up there and I'm making a note so I can go over what you guys asked. Oh, yeah. Okay. Okay, so with this one here, um, what would you want to do first? Alex, since you asked, what do you think you want to do first here?
Um, I said what did I do? I left two.
Yeah, so always deal with the domain effectors first. And so if I think about, here's my domain effectors here, and I'm going from a high of 4 and the low, well, I guess I made the low -4. So the first thing I would do would be going left 2, as you just said, right? So if I go left 2 and this one would be and I'm looking like this, right? So
Yeah,
far. Uh, why actually am I gonna, I mean, I could keep going, but why am I gonna stop right now? Or why is it okay if I stop there?
because you got the absolute value.
Yeah, because after I go left two, in fact, one, I'm doing it because I want to make sure to get everyone's questions, so I'm trying to cut time off. But also, I noticed the fact that because the next thing I'm going to do is the absolute value in X transformation, everything now that I've shifted to the left to, everything to the left of the Y-axis is going to disappear. And I'm going to reflect whatever's here on the positive side to the negative side. This one was up at 2. All right, so this, I haven't touched the range effectors yet. Okay, so now what next, Alex? That was just dealing with the domain effectors.
Now you go down one.
Down 1, right. And this is where I want people to be very careful because there was a mess up on the quiz related to this. Oh, this should be, sorry, this one should have been over here. So I went down 2. Would I go? Down 1, sorry, not down 2. Okay, now what?
Then flip over the x-axis.
Yeah, in fact, this is where I want people to be careful. Whatever's on the x-axis or above, mark that first, and then anything that was negative now becomes positive. So I'm up here, like that. And then this one comes up here. People get that? That pinkish?
On the test, if we bring like colored pencils and do it kind of like that, and we tell you which color is like the final answer, can we solve it like that?
Totally. And I'll have colored pencils too that people can borrow if need be. Yeah. I personally like to do it in steps, especially if it's something complicated with an absolute value, because I'm more likely to mess up if I try to do it all at once.
Yeah.
Okay, so switching gears, and I'm going to one by one get to the questions in the order they asked here. So, a question on Addie, I think you had a question on 1.12, whoops, to 13. Is that what you said?
Yeah.
Yeah, so this is comparing different types of transformations, and what you're trying to decide when for sure would they not intersect, and when might they intersect. And I would not draw, don't think of like a line that's too specific. Think of just drawing any generic graph for f of x. So if I have f of x, I'll draw f of x in like in black here. So say I have some random graph here. If I shift this graph to the left 3, we'll do that in green. So just everything shifted over. It looks like it definitely could intersect, right? Do you
Yeah.
agree with that? So these two can intersect. Depending on the graph, it might not, but it certainly could. But now
Yeah.
let's take a look at this one. Actually, I don't want that color. This one here, if I take my original graph, that black graph, and shift the y values up 3, so everything is 3 above, is that going to intersect with the graph?
Oh no.
No. So when every single y value for the same x value, if it's higher, there's no way it's going to intersect. It certainly can intersect this green one, but it can't intersect the original.
Okay, that makes sense. Thank you.
Yeah. Let's do a couple problems. The next request is a couple problems with here's a domain and range, and you're going to figure out what the new domain and range is, and then you're also going to tell me if you can't find it. Okay, so let's just do a couple problems like that. Again, I'm just going to make something randomly up. So say original domain was -7 to 4, and original range was -3 to 2. And you've got the original function is f of x. So tell me the domain and range, if possible, of the following. And I'll just do kind of a little bit more trickier ones versus the standard ones. Okay, so let's do y equals 3f -3 -1, something like that. Absolute value of, actually, I'm going to change that. Absolute value of x -2. And oh, actually, I'm going to change. Hold on. I'm going to change the second one. It's not what I wanted to do. Sorry. Sorry, I wanted to do that. Plus. Oh yeah, I do want to do that. And let me give you one more. Let's do 3f x squared. Okay, they're all a little similar in some ways with the range effectors, but the domain effectors are going to affect that. Okay, so let's kind of start approaching these. Again, I advise people, if you can, try to adopt the process of putting it between the extremes of the domain. I still feel like that's the best way to go about starting this, because it forces you to do the appropriate order of things. So I'm going to shift right 3. And so this will be -4 x squared to 7. Oh, sorry, x squared. Okay, what do you think from here?
Then you can cut out, or you got it.
I got it, or someone else got it? I
Oh,
got
no,
it.
I thought someone
know I
else was
got it.
speaking. I thought someone else was speaking. Sorry. I was just
I got it.
sorry.
I was just gonna say, you cut off the negative part because x squared can't equal a negative.
Exactly. So, and once I do that, before I even get to the domain, once I find myself doing that, I'm going to go range, can't find. So take care of that, baby. And then, great. So I need x squared to be less than or equal to 7. So what does that mean for the domain?
You could say x is like between negative root 7 to root 7.
You got it. Yes. If it's less than, if the squared is less than or equal to 7, then it's between negative root 7 and positive root 7. And that's your domain. Negative root 7, positive root 7. Yep. And so part of my graph got cut off because when I'm squaring things, it's never going to result in a negative. So whatever was originally associated with those negative values is no longer in play. So I can't find the range unless I had a graph in front of me, but I don't. And I'm not going to do a domain transformation with a graph involving x squared. We haven't talked about that stuff yet. Okay, next up, here we go. Between the extremes again, which was negative 7 and 4, gonna add 4. And once I do that, what do we say now?
Cut off the negatives.
Yep, once again, so range, can't find. Now what? So I got to deal with that absolute value in x transformation. So I'm just mirroring whatever's on the y-axis and to the right, to the negative side. So it's the only thing I'm mirroring.
Wait, aren't you adding 4?
Yeah,
So
aren't
then
you
it'll be
adding
less than or
4?
equal to 8.
Oh, did I subtract 4? Shoot, I meant it. I meant to have plus 4. Can we do plus 4? Sorry, I meant to show you if we did plus. I'll do minus 4 too, but let's do plus 4. I meant to have it to be plus 4 because I wanted to do this one. Sorry, we'll go back and do a minus. Thank you for pointing that out. Yes, it is supposed to be plus, but I meant it to be minus. Shoot, because I wanted to show you this one. Plus 4, sorry. So if I add 4, oh, so then this other side would be what if I subtract 4? Negative 11? Sorry, I wanted to do that. I'll do the other one in a second. I want to just point this out. So this still goes away. And so when I do the absolute value transformation, what's the only thing I've got?
0.
0, yes. Okay, so then what's the only thing in the domain?
2.
2, yeah. So the only thing I have is 2. Okay, sorry. I meant to do that one, but let's do the other since I put it up there. So let's do, if it had been, I'll just call it number 5. If it had been 3f x minus 2 minus 4 minus 1. So if I subtract 4, which means I'm going to add 4 to each, what do I get on both sides?
Wait, I'm sorry. How does a domain become only 2?
Oh, back to number 2?
Yeah.
Oh, okay. So do you see where we are right here? So we had x, so what we had was x minus 2, the absolute value, was between, when I subtracted 4, it was negative 11 and 0. Do you see that part?
Oh, yeah. Sorry. Yeah, I see it.
And so the only thing that's left that's 0 or positive is 0. So that's why the only thing I'm mirroring, think of it like a single point on the y-axis, everything else has gone away. And then I shift that single point to the right too.
All right, thanks.
Yeah, I'm sure I threw you off because I was doing the wrong problem before. So okay, add 4 and we get negative 3. X minus 2 to 8. Once again, similar deal, right? This was this is no longer in play. So what was the absolute value transformation? What would it go between then?
-8 and 8.
Yep, -8 and 8. And then I'd shift it right to, which remember graphically will mean now it's no longer symmetric across the y-axis. It's now symmetric across x equals 2. So 10 and -6. And can we find the range here?
No.
No, because we did this, right? So we can't find the range. Okay. Third one here, absolute value of x minus 2 plus 5. So -7 to, what was the other one I had it between? The original, sorry, I'm losing my screen. -7 to 4. Okay. Now what? Subtract 5, right?
Yeah.
And what would you guys say if this is what you get?
There is no domain.
Yeah, there is no graph, no domain, no range, no graph. So can't find either because they don't exist. So that would be it. Okay, let's do next one. X squared minus 7 between 4, -7. Oh yeah, this is what I meant to do for this one. All right, if I add 7 to both,
Miss Jensen,
yes.
just to clarify on the past one, so when you take the when you have a absolute value in the domain effectors,
Yes.
and both the domains are negative, there's nothing to move across the y-axis, so you can't find it, right?
Yes, exactly.
Okay.
So there actually is no graph. Yes, nothing. You can't do that transformation. It will result in no graph. Exactly. So you can't
Right.
either.
Okay, thank you.
Okay, so here's what happened. I added 7 and I've got x squared between 0 and 11. So what do we think?
-√11 to 11, or √11.
Yeah, and have I and more also importantly, have I lost any of my original graph before I
No.
reflect?
No.
No. Okay, so I'm not canceling anything out. So -√11 to √11. And then, so now what will I do for the range?
Wait, sorry, really quick, will you explain why you're not losing anything in your graph?
Yes, because, so notice, can x squared be 0 all the way through 11?
Like, yes.
Yeah, so there's nothing. So think about kind of similarly if the absolute value, think of it's because it's going to be a similar type of transformation, at least in terms of thinking about finding a domain and range, is everything after I've shifted it to the right 7, everything's either on the y-axis or to the right of it. Meaning I haven't lost any of my graph before I ended up mirroring it to the other side. So
Okay.
you know how before we would lose some of our graph because when you put it into this transformation, you would never get a negative. In this case, I'm still going to retain all the original values of my graph. So I will not lose any of the original range. It'll be transformed, but I won't lose it. So in other words, I'm not cutting off any of my original graph. And the problem when you do that is you don't know what range values are associated with what you cut off. But that's not happening here.
Okay, thank you.
And so now I just applied the range effectors. So multiply by 3, since I've never done it before. It was our first time doing the range. I don't even remember what it was. Okay, so we're going to multiply by 3 and subtract 1. So what would be the range here then?
-10 to 5.
-10 to 5. Yes, exactly. Yeah. So that's why I find these inequalities helpful because I I'm actually like physically crossing something off if it's negative and doesn't make sense, and then I know I can't find the range. Okay, there was a request for 4B and C on 1.14. So let me see. Oh, these are very similar, right? I forget who asked. Do you still want me to do these, or do you have a better understanding? I don't know who asked, but
I think it would be good to go for 4B because I think it's a little different than the ones we like practice with.
Okay, great. All right, so 4B, so absolute value of x minus 3 is between the extremes, -2 and 5. Oh, yeah. Oh, and you're right, it is. Okay, so what do I do first?
Add 3.
Yep, so 1. And Arya, do you notice, am I crossing off any of the graph at this point here? Am I losing anything?
Sorry, I just walked away and came back. What happened?
Hello. So what I just shifted it to the right 3, and I have 1 is less than or equal to absolute value of x less than or equal to 8. So the question is, am I going to lose any of my graph?
No, because you already shifted it, right?
I already not only did I already shift it, is there anything to the left of the y-axis?
No.
No. Okay,
Correct.
so go ahead. Sorry. No, maybe you're not talking to me. Okay, so now this is tricky. So what is everything to the right of the y-axis is going to be mirrored to the left. So 1 to 8 is going to stay. So what's the negative side?
-8 or -8 to -1.
Yeah. Do people get that? So this is a little weird, right? Because right now, after I've shifted it, think of I have a graph that just goes from 1, this isn't what the graph looks like, but let's just pretend, from 1 to 8, right? That's my graph. And if I'm doing this absolute value in x transformation, this means I'm going to mirror it over the y-axis. So when I do that, it's going to look like that. Well, more or less. Pretend that looks the same. So there's going to be that gap between -1 and 1. And then the range, we didn't lose anything. So we're going to multiply the original range by 2 and subtract 3. So -6 to 14 and then subtract 3. So this should be -9 to 11.
Wait, so for absolute value of x problems, you're always going to reflect whatever's on the positive x-axis over to the negative?
You betcha, yes. It makes it an even function, yes. Everything, because think about when you put negatives into the absolute value, they're going to have the same y values as the positive. So it really is making that function an even function.
Ms. Jensen, that gave me a quick question about even functions.
Yes.
So even if it's whatever, like x squared, or if it's x squared minus 3, in absolute value, would that still be even?
Yes, it would, right? So if you had something like this,
Yeah.
yes, absolutely. Because putting that negative x in the x squared, right, is just x squared.
What about if it was just regular x? Would that be a neither?
Oh, wait, sorry. I was thinking of something different. If it was this, you mean?
Yeah.
Oh, definitely a neither. Yes, neither. Because if I put in -x, that x is changing sign, right? But that -3 isn't. And
Yeah.
another way to think about that, if that's confusing, you can also think of the visual, like the absolute value of x minus 3 is the absolute value graph shifted to the right 3, which
Mhm.
really doesn't look like an even function, right? It does not have y-axis symmetry.
Yeah.
So that's the other way to think about that.
Okay. Thank you.
Do we want to do C here? I just made a mess of this page.
Yeah, can we do C? Because I think it's like a range influencer this time, so it's a little different.
Sure. Let me just make a little room here. Okay, so let's do the domain piece first, which is just the 2x minus 1. So be careful not to confuse the two because there's a lot going on here. But the only thing inside f is 2x minus 1. So between, oh gosh, I lost track. What, a negative 2 to 5. There we go. Okay, so we add 1, negative 1, 2x, 4. So negative 1/2 to 2.
It's to 6, right?
Added 1. Thank you. So negative 1/2 to 3. Thank you. Yeah, if I make a little mistake, let me know, please, before I get too far down the path. All right, so great. So negative 1/2 to 3. And now coming out of this function is, what is the range? Negative 3 to 7. All right, so let's do the order of things. First, I'm going to multiply. Nope, I'm not. There's an absolute value there. What's the first thing I'm going to do?
Minus 5.
Minus 5, right. So I'll have negative 8 to 2. Okay, so be careful with this. The absolute value in the range means anything that is 0 or positive, any output that's zeros or positive stays the same, and negative outputs become positive. So what's the low, if I'm doing the absolute value of the range, between negative 8 and 2?
2.
0.
0.
It has to. So yeah, so the trick is you think 2, because you think, oh, I'm going to take the absolute value of the extremes. But remember, zero's in there. So if zero's in there, 0 will still be the lowest. But now the new high won't be 2. The new high will be 8. Right? Because think of, you have all these y values between negative 8 and 2. 0 and positive stay the same. So 0 now is your new low, and 8's your high. And then I multiply by 3 and subtract 1. So this will end up being negative 1 to 23. Is that good? Okay, I'm going to give you a little, because someone asked for this. I'm going to give you a little challenge here. See how you do with this. Again, it requires me to graph, which not the best. Okay. And maybe I'll do that. Okay, so this is, oh boy, how do I want to do this? Because whenever I make these stuff off on the fly, sometimes they're not going to be pretty. So forgive me if it doesn't work out beautiful, but I'll do my best here. 1/2 f of let's do 2x plus. Okay, so This is the graph of y equals 1/2 f of 2x plus 1. Graph f of x. So we've had a couple like this where instead of me giving you the original and you're transforming it, I'm giving you the transformed and you're finding the original graph. Okay. Daniel, I think I hit the one about excluding a range of number. Oh no, what about making a function? Oh, okay, maybe I'll try to find one of those. 1.14, 1C. Okay, so oops, there we go. What do I do? Always do the x's first. What do we have to do here if we're undoing it, if we're going back to the original?
You have to find the inverse of 2x plus 1.
So actually somewhat the opposite. So think about, although maybe we're saying the same thing. Think about if I were going from f of x to 1/2 f of 2x plus 1. And if I were doing the domain transformations first, I would do reverse order of operations, right? I would do left 1, and then I would horizontally shrink by a factor of 2.
Yeah.
So if I'm though going back to the original, I'm going to do the exact reverse. So I'm going to go, so if I'm going from here to here, I'm going to stretch by 2. That's the first thing I'm going to do. And then I'm going to go right 1. So when you're going from a transformed back to the original, you're actually doing the order of operations for the domain effectors. Normally we do the reverse order, but doing the reverse of the reverse means we're actually doing the order of operations. So I would take each x value and I would go stretch it by 2 and then go right 1. And what would I do with the y values?
I have a quick question.
Yeah.
So you know how normally when you're given f of x and then you're trying to make it transform, you start with a domain. Would you
Yep.
want to start with the range if you're doing the opposite, or does it not matter?
No, still do the domain. Still do the domain. That's all. It actually doesn't matter, but I always do the domain just because sometimes weird things can happen with the domain. So it's just a good habit to always do the domain. Good question. That order doesn't matter.
Okay, thanks.
So normally, if I was going from the function to the transformed, we just talked about what we would do with the x's. And then the y values, we just multiply by a half. So if I'm going back, what am I going to do with the y values?
Multiply them by 2.
Yeah, multiply y values by 2. Yeah, so basically how you do things completely switches. If you're going back to the original, the domain effectors follow the order of operations, and the range effectors are now the reverse order of operations. I'm just more so used to doing this now, so I always list this out first, and then I think about undoing this, just so I don't get confused.
So just to like clarify the way that I'm doing it, like the domain of the way that you're doing it would still be -9 to 11, right?
If we're going to f of x.
Yeah.
So yeah, so if I stretch, I don't even know what was my original domain. 1, 2, 3, 4, 5. Oh, -5 to 5, right? Was
Yeah.
originally. And then yeah, so -10 to 10, so -9 to 11. Yep.
Okay.
Okay. Because there's a lot of questions. I'm gonna keep it a going here. And 20 on one, I'm gonna turn to 1.12 because there were a few questions on there. Okay, let's move on to 20 here. Oh yeah. I like this problem. It's just kind of a little bit of a fun problem, not really having to do with anything specifically other than functions. So if I plug in -3 for x, I get what's -3 to the fourth?
81.
Yeah, so I've got 81a minus 9b minus 6. All I'm doing is plugging in, right now I'm doing f of -3. So when I plug in -3 for x, minus 6 plus 1, and I know that equals 4. Or in other words, 81a minus 9b equals 9. Does that look right so far?
Yeah, I think that's correct.
Okay, so now, okay, I mean, I can reduce this by 9, but I'm not going to fool with it for a second because I want to figure out if I want to find f of 3, that's going to be 81a minus 9b plus 6 plus 1, right? That's what f of 3 will be. But I just learned what 81a minus 9b is. What is this equal to?
9.
Equal to 4.
9, right? 9 plus 6 plus 1. So this will be 16. It's kind of more just a little puzzly type thing. Kind of random.
Is that type of thing going to be on the test?
This exact question is on the test. No, no, it's not. It's just to practice with functions. No, I mean, I don't know what, no, it's not going to be on the test. It's a good practice for this, but it's not on the test. No. Okay, I still want to stick on this because people had questions. So 17. Oh yeah. Okay, so 17. So a lot of these problems were trying to get you to think conceptually. So I've given you just 3 points, and they're all different x values, -2, 0, and 4. And the first question is, can this be odd? What are our thoughts there?
No, because it would have to have like origin symmetry and it goes through 0 to 12.
Yeah, in order to have an origin symmetry, or some of you know it from last year as rotational symmetry, it has to go through the origin. And that's problematic here. It's not going through the origin. So it's not going to have origin symmetry if it's going through 0, 12. So it definitely can't be odd. Not odd. So definitely no origin symmetry. Could it be even though?
Yeah.
It could be. We just don't have enough information. If I had given you that f of -4 is like 5, then you would say no. Because if it was even, the opposite sign of the input would result in the same output. So, but I don't give you enough information. So it certainly could be even, but it could not be even. We just don't have the points to tell us. So that was 17, and 9C on here. Someone had a question about. Oh yeah, another one of the domain and range. And so this is the case where what do we do if what do we think about if I'm completely cutting off a part of the domain? What type of function must I have?
Square root.
Yeah, square root. Right, exactly. We're not just cutting off specific values, we're cutting off a whole slew of values. So, I mean, you could do as simple as x minus 7/3. Sometimes you may have to fool with it a little bit so that you get, when you set up an inequality, you get greater than or equal to 7/3, which would be the case here. I mean, not the prettiest looking function, but that's okay. But right now, the range isn't right. Right now, the range would be 0 to infinity. How do I make it negative infinity to -3?
Give the negative sign in front of the square root and then take away 3 after.
Yeah, exactly. Yeah. This would flip it to go to negative infinity to 0, this part, but then I want it to go all the way only till -3. Yeah. Let me jump back to 1.14 to answer the few questions that were there. Oops. Okay, make sure. 5b. Oh yeah, okay, so here's a graph of g of x. If I want to find g inverse of 4 using this graph, how do I do that?
4 is the output, so you look at 4, y is 4.
Exactly. This means the output of g of x would be 4. So let's find the input that would give us that output of 4. And that would be what there? Is it -3? Yeah. Okay, moving along. So that was 5b and then 1. Oh, let's go up to 3. Okay, so domain and range. 3c of x. Oh yeah, this is a good one to do. And then we can go to 1c too. All right, so domain, what's the only thing I have to worry about here?
The square root not being negative.
Yeah, so x minus 7 greater than or equal to 0, so greater than or equal to 7. So domain would be 7 to infinity. And then I want to keep that in mind for the range, because if this was my only piece to my function, the range would be 0 to infinity, because when I plug in 7, I'm going to get 0, and 2 times 0 is 0. But I have to plug in 7 for all x's, right? So I want to think about when I plug in 7 for x, I'll get 21 minus 5 plus, we said 2 times the square root of 0. So what actually is my low value?
16.
Exactly. So don't just assume that when you find the extreme of your domain, that's going to make everything 0. Actually double check and plug it in to make sure. And we've had something like that before where we've had multiple square roots and it didn't make everything 0. It made one of them 0, but not everything. Then I said 1c. Oh yes, this baby. Okay, so f of g of x, I always do this first because this tells me right away that I need x to be less than or equal to 6. Right, because 6 minus x has to be greater than or equal to 0, so x less than or equal to 6. So right away, we have to consider the domain of the inner function. And if I put that into the outer function, 6 minus x squared, the squared and the square root undo each other. So I have -7. Just remember you're subtracting that whole quantity, which means distributing that negative in this case. So -7, 4 plus x. So, which means x can't be -4. So when you are doing a composition, it's the domain of the inner function and end result that matters. So the domain will be negative infinity, can't be -4, -4 to 6. And remember what else I said about compositions, that when you find the range of compositions, you really want to keep that domain in mind. And you can see here why. Because if I just looked at -7 over 4 plus x, x could be anything except -4, but we know that's not the case. X can be anything except -4, but the highest it can be would be 6. So I actually am going to do this to figure out my range. So -7, and if I do this, what is now my new low here?
Two.
So if I do this out, my low will be -7, 4 minus, oh, 4 plus. Why am I doing minus? Sorry, you would be right. It would be 2, except I put a minus instead of a plus. So try that again. If it was minus, it would be, but what would it be if I had it messed up? If I had put the plus, what would my,
Infinity.
yeah, negative infinity, 0, union, 0, and the high would be 10, right? Okay, so when we do this analysis, -7 over negative infinity will be
Negative infinity to -7 over 10 union 0 to infinity.
yeah, the positive side will be everything, but the negative side will get huge negative, but the closest I'll get to 0 is -7/10, right? This is a plus. Okay, let me make sure I've got everything. Okay, I'm gonna pop back to 1.12 here. And let's see, 17. Oh, I went over 17, right? Then 1.12, number 4. Oh yeah, how do we approach these types? We've seen this a few times, but they're always tricky. So I gave you a formula for f of x minus 8. How do I then find f of x?
Would you plug in x8 and insert it into the other part of the equation?
Yeah, you think of exactly. I think of what am I doing to get back to x? I have to add 8. So it's going to be 2x plus 8. So you're doing that reverse order to get back. And no need to simplify. You just leave it like that. Same as like say I had said this equals f of x over 2. How would you find f of x? So again, say this was the formula for f of x over 2. How would you then find f of x?
You plug in 2x everywhere.
Yeah, you plug in 2x everywhere. Exactly. Right. I have time for like one more question. Did I miss anybody? I'm trying to think. Tried to write down all the ones as we were going. But feel free to chime in if you have a last question. Just shout it out.
Can we go over question 19 on 1.12?
Yes, am I on? I think I'm on 112. 19. Oh yeah. Okay. Yeah, this is another weird one. Okay. So find for has the property. Okay, if f of 2 is 7, then calculate f of 12. Okay, any ideas?
Do you do the f of 2 twice and then the f of 3?
Yeah, so walk me through that. So we're going to use this fact here, right?
Yeah. So, in like the f of m, I put f of 2, and f of 3, which we know is 6.
Okay, wait, let's back up. So you said f of 6 equals f of 2 plus f of 3?
Yeah.
Okay, great.
And then I took that f of 6, which is really just those two, and then I did that, and the f of 2 again, and that would give you f of 12.
Yeah, so okay, so let's back up. So f of 6 is, do people agree, based on this formula, it's 2 times 3. So I can do because we want to be able to use this right here. So f of 6 I can think of as 2 times 3, which is f of 2 plus f of 3, and then we plug in what that is, which is 17. Right, Danny? Who was helping me with that?
Yeah.
Yeah, okay. Thought that was you. And then you said, okay, and then your next thing was, well, f of 12 then is f of 6 times 2. So I could write this as f of 6 plus f of 2.
Yeah.
Okay. And that would be 7.
You put another 7.
17 plus 7, right.
Mm-hmm.
24. Does that make sense, Addie?
Yeah.
It's just that was just another cute problem solving, kind of not much to do with what we've been doing, but just using functions. Okay, so Sophie, and this will be a last question, but great question. So an even function, most functions, by the way, are neither, but if a function's even, it will have y-axis symmetry, meaning if you fold it over the y-axis, the graph will line up. So for example, a standard one would be the absolute value of x. That has y-axis symmetry and it's even. Or y equals x squared. That's even. Whereas an odd function has origin symmetry. And like a classic or a very simple odd function is y equals x cubed. And origin symmetry means, say we take part of the graph. If we take this part of the graph and flip it over both axes, so it's like you're rotating it around the origin, the graph lines up. So if I take this upper right piece and flip it over both axes, that graph will line up. That's odd. And neither won't have either of those things. So again, most functions don't have either of those symmetries. So it's just odd and even are special types of functions that sometimes happens. Does that make sense, Sophie?
Yeah.
Okay, great. All right, everybody. I'll see some of you tomorrow. D block, remember, you can start a little early. I'll be in there. Just because we've got a drill going on tomorrow that's going to interrupt the only the last couple of minutes of class, but so I want to give you guys the same amount of time I give everybody else. Okay, I'll see you tomorrow or Friday.
Thank you.
Thank
Bye.
you.
Thank you.
Thank you. Thank you.